Imagine something so powerful it can swallow over 20 billion stars. Sounds unbelievable, right? That's a black hole for you. These mysterious giants of the universe are both fascinating and baffling. If you step outside tonight and look towards Sagittarius,
We now have bagged some of the biggest black holes ever recorded in the history of science that have gobbled up over 20 billion stars.
You're looking at the center of our galaxy. There, a massive black hole, weighing millions of times more than our sun, quietly lurks.
It's something that fascinates us.
And in fact, if you want to see a black hole tonight, go outside, look in the direction of Sagittarius. That's where we have the center of the galaxy, and a black hole weighing perhaps 2 to 4 million times the mass of the sun, lurking right at the center of our own backyard.
Black holes are like cosmic vacuum cleaners, pulling in anything that comes too close. They're made of space, time, and matter, all squeezed into one tiny point. While their power is undeniable, there's still so much we don't know about them. Despite this, they continue to capture our imagination, reminding us how strange and wonderful our universe truly is.
Photograph is the smoking gun. First of all, the black disk in the center is the event horizon, the point of no return. You fall through that event horizon and you never...
This photograph is the smoking gun. The black disk in the center is the event horizon, the point of no return. You fall through that event horizon and you never come out. Scientists have been studying black holes for decades, and they finally figured out the inner workings of one. Join us as we discuss what it's really like inside a black hole and how this discovery might change everything. But before we get to the current discovery, we need a bit of background. Although most of us grew up knowing that black holes were real, there was a time when they were just a theory until the first black hole was discovered in the late 1960s, known as Cygnus X1. From this discovery, scientists gained some insight into how black holes work and behave. For instance, they found that a black hole is an incredibly dense area of space-time with such immense gravity that nothing, not even light, can escape from it. They also discovered that black holes come in different sizes, with the biggest ones being around 200 kilometers across and the smallest ones being tiny, about the size of an atom. Cygnus X1 is a stellar mass black hole, which means it's only 6 times bigger than our sun, but has the same mass. The discovery of Cygnus X1 also revealed that black holes tend to have strong magnetic fields, as well as a powerful gravitational pull. This makes them incredibly dangerous and capable of causing serious destruction in the universe if left unchecked. This discovery enabled researchers to learn more about how these powerful cosmic objects work and to develop theories that allow us to better understand these mysterious phenomena. From this discovery, we also learned how rare black holes actually are. It turns out that there may be close to over 1 million in the Milky Way alone, yet they are still incredibly hard to detect, leading many to speculate that the actual number could be significantly higher. If there are that many in our own galaxy, we need to learn more about them, and thus began the journey to really understand what's inside a black hole. In essence, when something enters a black hole, it is trapped and compressed down astronomically until it reaches a singularity, the main mass point of this entity, where all matter is essentially crushed into one single particle. But before reaching this point, there are 2 layers of the black hole that one must travel through in order to reach this singularity. The first layer is known as the outer event horizon, a boundary surrounding the mouth of each black hole where anything entering it will not be able to escape due to its incredibly strong gravitational pull. This layer is responsible for trapping and slowing down anything that falls into it, so much so that to escape it would require traveling faster than the speed of light, an impossibility at this time in our current understanding of physics. This is also the point where the physics of our universe stops working, replaced instead by a new set of chaotic laws that govern what goes on inside. The second layer is known as the inner event horizon. A black hole acts as a gateway leading toward the singularity, where real danger lies. Once a particle enters this layer, it has no chance of surviving or escaping and is almost certain to be crushed into a single point of matter. At this point, gravity is so powerful that it bends even light itself, while time slows down and temperatures become unimaginably hot. This means that not only is matter being crushed, but it is also being boiled alive. What makes black holes so dangerous is their completely different gravitational pulls, making them incredibly difficult to study and predict due to their unpredictable nature. Furthermore, their strong gravitational pull makes it impossible to observe them directly. Scientists rely on observing stars that orbit nearby these entities to gain meaningful information about what lies inside them. Imagine needing to study an overwhelmingly powerful thing in space, but it exists in 3D while our observations are limited to 2D telescopes and pictures. Going inside a black hole is impossible because once you go in, there's no coming out. The fundamental impossibility of traveling fast enough to escape their gravitational pull means scientists are limited to studying black holes from afar, which is challenging given their size and complexity. They observe the radiation black holes emit and the dust and gas surrounding them. Creating a detailed image of what's inside is incredibly difficult, as any probes or cameras sent out would be instantly crushed by the event horizon once they reached it. Additionally, every black hole is unique in its formation and behavior, so there is no single standard model. Physicists have been unable to make sense of the singularity at the center of all black holes due to current technological limitations. This means that all we can do is theorize about what might lie within, but nobody will truly know until we find a way to transcend the boundaries of space-time and travel faster than light. Moreover, black holes are constantly changing and evolving as they absorb matter, energy, and radiation from the universe around them. This means that any data gathered from observing a black hole could quickly become outdated. Despite the dangers and mysteries surrounding these massive astronomical phenomena, they can still be studied and understood to an extent. By mapping out stars close enough to the event horizons of black holes, scientists can observe them from afar and gain valuable insights into their structure and behavior. This knowledge has allowed us to explore space safely and develop theories about what lies beyond the event horizons of these mysterious entities. One intriguing theory suggests that black holes might be gates to other galaxies and universes. Inspired by the movie Interstellar, this theory proposes that black holes could provide a gateway to faster-than-light travel, allowing us to reach galaxies and universes beyond our own. However, this theory remains purely speculative, as it relies on the creation of technology that can travel faster than light. There are also practical problems, such as the immense gravitational pull and radiation of black holes, which could trap any spacecraft entering them. Moreover, what lies beyond the singularity remains unknown. Nevertheless, scientists are already working on creating a spacecraft capable of faster-than-light travel, and black holes might be one of the first things they investigate further. In an effort to simplify the complex concept of black holes, Enrico Rinaldi approached it differently by combining theories of particles and gravity into what is known as quantum matrix models. He proposed a new theoretical concept called holographic duality, which suggests that we should view black holes as holograms. This theory posits that the outer space around a black hole plays an important role in its function, indicating an ongoing cycle of energy, rather than a singular point where all matter compresses. According to Rinaldi, the particles and gases in outer space provide the fuel that powers a black hole. By viewing a black hole as a hologram, we can see how these elements interact to create something new. This presents a different picture of black holes as constantly consuming dust particles and gases, allowing them to continue growing in size. The implications of this new theory are exciting, as they could lead to a better understanding of black holes and their behavior, potentially enabling us to harness their energy for our own purposes. While it remains uncertain whether this theory is correct, it provides a more exciting perspective on these powerful objects. As technology advances and our understanding of black holes deepens, the possibility of unlocking new secrets remains open. Only time will tell what discoveries lie in store, but it is clear that our understanding of black holes will continue to evolve and fascinate. On that note, we'll wrap up today's discussion. What is your theory about black holes? Let us know in the comments below. If you enjoyed this video, please give it a thumbs up and subscribe to our channel for more content like this. See you in the next one.